just a quiz correction. So the first one basically deals with two angles of elevation because it's from the horizontal. Note that we know the distance, the horizontal distance from the base of the building to this point right here. And so just one side, you need at least one side, and we've got these two angles here. The first thing I would suggest is try to find out as many angles as possible. So 42 minus 31, right? That's right here. So this little sliver here is 31. Oh, sorry, 11. So we've got that figured out, and then just continue your journey around, all around that triangle. So you know that there's a 90 here. So if you consider the 31, you can actually find out this is 59. It's hard to see, but it's 59 there. There's a supplement here. So technically, this one up here is 121. Right, you figured that one out. And then you can work with this obtuse triangle here and figure out this top angle right there. And now you've got basically all angles just like that. Doesn't take a whole lot of time. Just have to be careful, right? So you've got all angles. And then you have to figure out which triangle are you going to start with. Which one are you going to get going with? So I would suggest the 24 has to show up for sure. So if you're comparing the 59 to that one, that means that you're in this triangle right here. So what I did is I used this as my pair, just like that. And then sine of 90, this corner, allowed me to find side y. I solve, I don't round because I'm not done yet. A lot of you did round, but it didn't affect your final answer, so you were fine. So 1 mark, 1 mark. Then, now that I have y, I can move into this triangle right here. And so I want to know the height of this sine. So I use sine of 11 will help me get there. I'm going to now shift over to this angle here, which is across side y. So that's my pair, right? The number I just found comes with me. And then sine of 11 over x. Cross multiplying the divide, you get the height of the sine. Some of you found the entire height here. From the bottom to the top of the sine, and then you proceeded to find the height of the building, and you just subtracted it to get x. That is fine, very totally doable. I'd say the same amount of work as I did. Okay, next. We've got a police helicopter flying 400 meters above the highway, so we've got the 400 height here. Notice that what this question is not saying, it does not say that the helicopter is somewhere in between the crash site and the ambulance, right? So it could have been anywhere in between. If it doesn't say that, then we're assuming we're off to the side, either to the left or to the right, looking over to the same, in the same direction, so to speak. And you have to know that the one that has the higher angle of the bigger number of for angle of depression is going to be closest to you in this case, because right, like you have to look down further. So the collision first, then the ambulance, because it's a 62-degree angle of depression from the horizontal, right, to the collision, and it's a 27-degree angle of depression from the helicopter to the ambulance, right? So you've got that going on. So these numbers should have been there right away. The 400 is there, so that's given. And then I start figuring out different angles. So for example, right, this 27, alternate interior to this one, it touches that transversal right there. Some of you figured out 62 minus 27, right, that this is 35, and you said, oh, 35 goes here, and that's incorrect. The 35 is between the two diagonals. You want this one here, right? So this is 62 right here, which also comes back there. So that does transfer. And then you just have to be careful, find as many angles as possible, right? You've got supplementary here. This one I already have. The 35 you already have. By subtracting these two, you could have used sum of triangle. Using these two, regardless, you get 35. Okay. So this is your diagram, and it's asking direct distance between the helicopter and the collision is the first question, so that's x. So after having found a whole bunch of angles and whatnot, I'm going to use the 62 across the 400, because remember, you have to use the 400. I will resort to this triangle right here. It's a right triangle, because the height is always measured with respect to, or 90 degrees with respect to the ground. So that's my pair. That's what I start off with. And then the sine of 90 helps me to find this, which is the direct distance right there. So that's how you find x. A lot of you found that. Now I switch over to this triangle. And the question B is asking how far apart is the collision and the ambulance? How far apart are they? So I'm going to now pair up the angle 27 with the side I just found right here. And then the 35-degree angle up here between the two lines of sight will give me y. Okay, so you solve that, and then you get that distance. And obviously, if you sketched it in such a way that the ambulance, right? If the ambulance is somewhere in between, the helicopter is somewhere between the collision and the ambulance, obviously, you have an angle depression here of 62, and you have an angle depression of 27 here. And this is the scenario you're encountering. And the 400 would be down here. So most of you would have then figured out x and figured out y and added these up to get that, and that is actually a correct step if this is how you drew your diagram. Okay. So again, if it doesn't say that it's in between, assume that it's not. Okay? All right, back side. Here we have, right? Elijah is traveling 13 kilometers south, 15 west. So this is my south line. I turn 15 towards the west. Okay? So the 15 is there for 13 kilometers. And then we're told that we're going 11 kilometers in the direction west, 10 degrees south. So this is your west, and it's just a small angle, so it's 10 degrees south. So it's going this way for 11 kilometers. This is what I would have expected you to interpret or have as your interpretation. Then you come up with your clean. You know that there's a 90 here between the dashed lines here. And you have the 10 here, and you've got the 15 here. Remember, the 15 came with you, right? Because these two lines are parallel, so we use the alternate interior property. And so we get 115. If you add 10, 90, and 15, right? 10, 90, and 15, you get the 115. It's SAS. That calls for cosine law, and you go ahead and solve. It should be pretty straightforward at this time. And then question 4 required a bit more work. So we're told that the search and rescue team is doing an exercise. The crew left the heliport H, right? So this is H, 45 kilometers in the direction north, 25 east, right? So the compass rose to start. This is north. You go 25 towards east, and then you travel 45 kilometers. At that point, you turn, and then it says that we're flying south 51. So this is south. We turn 51 degrees in the east direction, towards east. Travel. We don't know where we end up exactly, but we want to make sure we don't assume that we're lining up perfectly with our origin. Okay, so I'm going to go a little shorter. And then it says that the destination D is 75 kilometers from the heliport. So we know that this side is 75. I bring the 25 over to fill in this sliver here. When you add that up, you get 76 degrees and the two sides. You've got a pair and another side, as I say, that calls for sine law. All right? So you go ahead and it's asking, right? Calculate the distance flown from the second leg of the trip. Okay, so we're wanting this. This is our pair to start off. And then the only thing you can do at this moment is use this side to figure out the angle across from it, which is angle D. We solve for D, then we solve for angle H using sum of triangle. We use this angle we found again, right? So we use our original pair. Now we use this angle, which is right here, angle H, to figure out side TD. You solve for side TD at 71.87. C is asking the total distance the crew has traveled, and obviously we add up these two sides here because that's what was traveled, right? Start here, get there, turn, and fly to your destination. So it's only these two sides that we want to add. It's 116.87. And then D, the helicopter flies 160 miles per hour. How long would the training exercise have taken in hours? So we have two options. I'm going to turn my 160 miles per hour to kilometers per hour. So I turn it, I convert it, knowing that 1 mile has this many kilometers. Once I have my speed in kilometers per hour, I say that, right, this speed in an hour, so this many kilometers in an hour. So how long would it take to go 116.87 kilometers, right? It comes right from there. You cross multiply and divide, you get 45.38. If you turn that into minutes, it's 27.23. But it said an hour, so 0.45 would have been acceptable there. That's it. Hope this helps.